Hi, welcome. So, I'm going to teach you something. It's called the Rule of 56. The Rule of 56 is what every college student should know and follow. So, this would be a 3 credit course if you were taking it in class. And the 3 credit course means that we meet 3 hours a week for 15 weeks. So, if you're taking this course in shorter amount of time, you would have to figure out the time that you would be spending in class per week for this so that you would know. So this is math, and typically people struggle with math. And the hours in class that you are in a course would be, this is a 3 credit course, so we would be in class for 3 hours. Plus, for every hour you spend in class, you're supposed to spend 2 hours outside of class studying. So if you do 2 hours times the 3 credits, or 3 hours typically in a 15-week semester, plus the hours you work per week, it has to be less than or equal to 56 for you to be manageable. So this kind of tells you whether you could take um, a bigger course load, or if you should work less or work more, take less classes, that kind of thing. So in this, we have 3 plus 6, which was 9, plus the hours you work has to be less than or equal to 56. So the hours you work should be less than or equal to 56 minus 9 is 47 hours per week. So if you have one job for 40 hours a week, plus you're taking this class, you should be okay. Taking it in a 15-week class cycle. If you're taking this in our 7-week cycle, then multiply this by two, because this 3 would now be 6. So it'd be 6 plus 12, which would be 18. So you should be working less than or equal to 36 hours a week. All right, so we're going to start right in with fractions. Fractions are my favorite. Oh, I love me some fractions. Okay, okay, okay. So fractions, I like fractions because nobody does. So there are 3 types of fractions, as you see here. There are proper fractions, improper fractions, and mixed numbers. We're going to first talk about proper fractions. Proper fractions, if you think about the word proper, if you go out to eat and you're at a restaurant and there's food all over the floor, or people just don't know how to behave, proper fractions, it, or, man, let me start that over. Proper, you go out and there's not food on the floor, people are behaving, then you think that it proper, it just looks right, which means a fraction then that looks right is when the top number is lower than the bottom number. So you would have something like 3/8 or 1/4. Improper was like the first thing I described, where you go out to that restaurant and there's food all over the floor and you're not at Texas Roadhouse, or people are eating with their mouths open or loud or obnoxious. They're really improper at that restaurant. Well, improper fractions would mean that it doesn't look right, which means the top number is either the same or higher than the bottom number. So an improper fraction would be something like 8/5 or 2/2. Those are improper. They don't look right. A mixed number is a whole number next to a proper fraction. So you have something like 9 and 3/8, or 4 and 1/5. Those are proper fractions with whole numbers. It cannot be never. Never would be something like 5 and 6/5, or 12 and 25. Well, 25th. Why don't we say 23rds? Those are just weird. That looks strange. Don't stop your answer looking like this. change it. We'll show you how in just a minute. So, the first thing that we're going to do is we're going to change an improper fraction into a mixed number. So we're going to change an improper fraction into a mixed number. So if you have something like 19 over 5, we're going to divide the bottom number into the top number. So the way that you can remember this is, if I have 19 over 5, and I draw the fraction bar, then the 19 falls in the house. So 5 goes into 19 3 times. And my remainder is 4. So 3 whole times, so that's whole number. 4 is the parts left out of 5. And that's your new numerator. I do this all the time. We're going to keep going. So then my final answer would be then 3 whole numbers. 4 is the remainder, and 5. Keep the 5 bottom part. When we change a mixed number into an improper fraction, then we have something like, well, let's take our 3 4/5 and make it back into an improper fraction. We're going to multiply the whole number times the denominator, and then add the numerator, and it's going to be all over the same denominator. So that denominator does not change. It's still going to be out of that 5 parts. So in this case, it would be 3 times 5 plus 4 all over 5. So 3 times 5 would be 15 plus 4 all over 5. So it would be 19 over 5, which, look, that's what we had before. What? That is awesome. So remember how we said we're going to fix the number if it looks strange? So wow, that's strange. Let's fix it. Let's go back to this and let's change. If I have 5 6/5, it means I have 5 plus 6/5 of another part. Which means I'm going to change this into an improper fraction. So 5 goes into 6 one time with a remainder 1. So 5/6 goes in one time with the remainder 1. So that's your new numerator. I have to still add that to my whole number 5 from before. So my final answer would be 6 1/5. So I can say that 5 6 over 5 would be equal to 6 1 over 5. So you try the 12 20 over 3. Pause the video, try it, and come back and see if you did it correctly. So here I have 12 plus 20 over 3. So I'd have 12 plus 3 goes into 26 whole times, which is 18. Then I have 2 left over. So 20 over 3 would really be 6 2/3. Now that I have that, I'm going to add my whole number, so I have 18 2/3. So instead of writing 12 20/3, I'm going to write 18 2/3. Cool? Okay. So let's move on to, we needed to know all that so that we can add fractions. Oh! When we add fractions, we are going to follow these rules. First, we're going to separate the whole number from the fraction. We're going to add the fractions first. Remember, we're finding a common denominator when we add fractions. And after adding, if the fraction is improper, we're going to change it to a mixed number and add the 1 to the whole number in the problem. And then at the end, we're going to add whole numbers together. So, Let me get a color here. All right, let's do green. So say you have the number something like 12 and 4/9 plus 5 and 5/6. So the first rule says we're going to separate the whole number from the fractions. I'm going to separate that. And then I'm going to add the fractions. Remember, finding a common denominator. In order to find a common denominator between 9 and 6, I'm going to take the higher number and double it and see if the bottom number goes into it or the lower number goes into it. So here I have 9 and I double it to 18, and then 6 goes into 18, so I can use that as my denominator. Now because I multiplied 9 by 2 to get 18, I'm going to multiply 4 by 2 to get 8. Because I can say that 4/9, an equivalent fraction, is 8 over 18. With the 5/6, I'm going to multiply 6 by 3 to get 18. Notice I didn't multiply it by 2 because 6 times 2 is an 18. I had to multiply it by 3 to get 18, so on 5 I'm going to multiply that by 3 as well, and I'm going to have 15. Now that I have the same parts on the bottom, I can add my fractions together, and I'm going to get 23 over 18. 23 over 18, if we make into an improper fraction, or a mixed number, 18 goes into 23 one whole time, and then you have 5 left over, so it's 1 and 5/18. When you add these two together, you're always going to get a number less than 2. So this here is more than 1, but it's going to be less than 2 because I had 2 fractions up here that were less than 1 each. So this number, after you get here, if it's more than 1, it's going to be 1 and then the difference between the top and bottom number. That's kind of like a little secret. So when I add the numbers, it's 1 and 5/18. Now I can add my 12 plus my 5 plus my 1, and I have 18 and 5/18. Now I want you to try one. I want you to try 4 and 11/16 plus 3 and 7/12. And you're going, oh no, why did you give me 16 and 12? Because I told you a way easier, an easier way to get a common denominator, and I want you to use that for this class. So if I have 16 and I double it and get 32, does 12 go into 32? Absolutely not. But if I have 16 and I multiply it by 3, I get 48, and does 12 go into 48? Absolutely. So we can use 48 for that. So now I want you to figure out how to do this problem. Put me on pause and come back when you're done and see what it is. So I'm going to continue. 16 times 3 is 48, so 11 times 3 is 33. 12 times 4 is 48, so 7 times 4 is 28. And now that they're the same denominators, I can add the top numbers, and I get 61 over 48. And because I know that it's going to be less than 2 and that it's more than 48 here, so it's 1, I can say 48 goes in there one time, and the difference of those two numbers will be 13. Then I can add 4 plus 3 plus 1, and I get 8, and 13 over 48. What? That is awesome! I'm going to ask you to do one more. So if you have 8 and 7/8 plus 2 and 5/6. Go ahead and pause. Figure it out and come right back. My common denominator, if I multiplied this by 2, I get 16, and 6 will not go into 16 evenly, so I'm going to multiply 8 by 3 and get 24. And 6 does go into 24 evenly, so that's going to be my denominator. In order to find my numerator, I'm going to go times 3 to get 21. Times 4 to get 20. 21 and 20 is 41 over 24. And 2 plus, oh, just kidding. 24 goes into 41 one time with a remainder of 17. And I can add 8 plus 2 plus 1 and get 11 and 17 over 24. What? That is awesome! All right, let's go to subtracting fractions. Oh, when you subtract fractions, you're going to separate the whole numbers from the fractions, and then subtract the fractions first in case you need to borrow from your whole numbers. Borrowing goes like this. We're going to take a number away from your whole numbers and add the whole number to the front of the fraction beside your problem. We're going to make that mixed number an improper fraction and then rewrite the bottom fraction under it so that we can subtract and reduce. Sounds like a lot, but we're actually going to be okay with this. In order to subtract fractions, we have the number 12 and 3/7 minus 2 and 3/4. So I'm going to separate my whole numbers from my fractions and get a common denominator. My common denominator is just going to be 28. So 7 times 4 was 28. So 3 times 4 is 12. 4 times 7 is 28. So 3 times 7 is 21. Now I can't subtract these two because 12 is bigger or smaller than 21. So I can't take 21 things from 12 because I don't have enough. But I do have a bigger high number here, whole number. So I'm going to change that to 11, and the one that I borrow is going to come in front of this fraction. And then I'm going to make this fraction now improper, mixed number improper, make improper. And remember to do that, we did 1 times 28 plus 12. And it's all going to go over 28. So 1 times 28 plus 12 happens to be 40 over 28. And this bottom number is going to stay the same. Stay the same. So it's going to be 28, and the top number is 21. But now I can subtract it because 21 is less than 40. And when I subtract it, then I have 19 over 28. And don't forget your whole numbers. 11 minus 2 is now 9. What? You should try one. I want you to try one. The one that I want you to try goes like this. So now you can try 9 and 4/9. Oops. Minus 6 and 5/6. Again, turn this off. See if you can do it. And come back and see what answers I got. All right. I want to continue. So if I first separate the two, and I have 4, I have 9 and 6, and if I double 9, I get 18, and 6 goes into 18, so I'll keep 18 as my denominator. It'll be 9 times 2, so it's 4 times 2 to get 8. It'll be 6 times 3, so it's 5 times 3 to get 15. And I cannot subtract 15 from 8, so I'm going to borrow from my 9. When I borrow from my 9, it becomes an 8, and the 1 goes right in front of that. Then I take my my mixed number, and I make it into an improper fraction. So I take 1 times 18 plus 8 and put it all over 18. So then I have 26 over 18. And now I'm going to keep the bottom one the same. And I have minus 15 over 18. So then I have 26. And now I can take 15 from 26. And when I do that, I get 11. And I can take 8 minus 6 to get 2. I know, right? That was awesome. Okay, let's multiply fractions. When you multiply fractions, first you're going to change all your numbers into fraction form. So if you have mixed numbers, improper fractions, oh, they should be improper fractions. And then cancel out factors from the numerator and the denominator. And it might help to break up the numbers down one at a time. So you can do this however you learned how to do it. Or if you get big numbers such as this, you could also go, all right, well, 15, I'm going to take that and say that's 3 times 5. 5, I'm going to leave alone. 56, I'm going to leave that alone for right now. 24 is 3 times, I see this 3 that it's going to cancel out later with, so I'm going to say that's 3 times 8. 9 is 3 times 3, and 25 is 5 times 5. Now I'm going to go back to this 56. 56 is a weird number. I can break it down by 2, but if I look down here, I see 5 won't go into it, 3 won't go into it. I'm going to try if 8 goes into it, and 8 does go into it 7 times. So that's why I chose to break it down as 8 times 7, because eventually that 8 is going to cancel with that 8. But right now it looks like a hot mess, so I'm going to put it all on one line and say 3 times 5 times 5 times 8 times 7. 3 times 5 times 5 times 8 times 7. On the bottom, I'm going to go 3 times 8 times 3 times 3 times 5 times 5. So I had 3 times 8 times 3 times 3 times 5 times 5. And now it's easier to tell. When I have a number over itself, I get 1. So if I have 1 3 up here and 1 3 down here, I can cancel it. If I have 1 8, I can cancel with 1 8. Here I have 2 5s, and they can cancel with 2 5s. Now I only have 3's left down here and 7 left up there. So they can't cancel into each other. There's no common factors. So I'm just going to multiply across now. When these all canceled out, they became 1s, just so you are aware. So had I canceled the 7 with another 7 down here and there was nothing left, it would have been a 1 on top. But it's not the case. In this case, there's a 7 left. And down on the bottom, I have 3 times 3, which is 9. So my answer then would be 7 over 9. Awesome sauce. Awesome sauce. Now we're going to divide fractions. When we divide fractions, we're going to first change all your numbers into fraction form. And then you're going to cancel out factors from the, oh, no, you're not. I'm just kidding. This step, I don't know why this is in our notes this way. Hopefully by the time I post these, I'll change this. But this actually goes right here. So bring it down. Because we're going to use the same change method for dividing fractions, which means that the first number stays the same. Then we're going to change division to multiplication and change the next fraction to its reciprocal. After we do that, we'll have a multiplication problem where we can cancel out the factors and then multiply what is left. Note, if nothing is left, place a 1 in the place of a fraction. So here I have 4 times 8 is 32 plus 3 is 35 and over 8. This is not a fraction, it's a mixed number, so I'm going to change it into an improper fraction. So 2 times 4 is 8, plus 3 is 11. Notice how I didn't skip steps, right? So I'm going to do this next. Now I'm going to keep change. So I'm going to same change, keep this the same. So it's 35 over 8. Change the division to multiplication and change that to 4 over 11. Now I'm going to check 35, and 35 doesn't have any factors with 8 and 11. But 4 does. 4 can go into 8 twice, so I can cancel out my 4's. Now 2 doesn't go into 35, 11 doesn't go into 35. That became a 1, and now I can multiply across. Now I have 35 over 22. If I put 22 into 35, I can say it goes in there 1 time with a remainder of 13. Five and 1/3 divided by 2 2/5. Go ahead and try that, and then come back on and see if your answer is the same as mine. But I'm going to take 5 and make it into an improper fraction, so I have 16 over 3 divided by 12 over 5. So I'll have 16 over 3, change to times, and change by flipping or taking the reciprocal, and then cancel. When I cancel, my 3 doesn't go into those two. But 16 has 4 times 4, and 12 is 4 times 3. So when I cancel with my 4's, now I have no common term, so I go 4 times 5 is 20, and 3 times 3 is 9. If I want to put it into a mixed number, I can go 9 goes into 20 twice, which is 18 with a remainder of 2. So it'll be 2 and 2/9. Yay! Ooh, the great debate. The great debate is this way for a reason. The great debate is this way to see, does 0 over 6 or 6 over 0 equal, which one is 0 and which one is undefined? Good question. Good question. All right, well, answer being, if 0 is under, it's undefined. When 0 is under the fraction bar, it is undefined. If I were to write it out the long way, this would be 6 divided by 0. Or it would be 6 goes into 0. How many times does a number... Just kidding, it wouldn't be that. I just messed that up, sorry about that. 6 divided by 0, if you make the house, the top number falls into it. So it would be 0 goes into 6. There's no telling how many times the 0 goes into that number. There's just no telling. There's an undefined amount of times. So therefore it's undefined. If we were to write this out, 0 divided by 6, it would look like that. If I were to write it in the house version of it, under the radical sign, then the 0 falls in the house, so it would be 6 goes into 0. Now if you think about it, 6 goes into 1 0 times, because it doesn't go in there that many times. So 6 goes into 0 0 times. That's why this answer is 0. You cannot write this as an answer, because in the finance world that means 0, and in the math world that means undefined. So if you wrote that for the answer, that's clever, but I wouldn't know which one you were talking about. So if you write your zeros with slashes on there for zeros, make sure you don't for this answer. All right, we're done with fractions. That is so sad. I wish we could do more. Good luck.